We're doing a limiting reagent problem where one of the substances will finish before the other, putting a stop to the reaction. But we start off by calculating a certain amount of product being formed, and from there back calculating to find out how much sodium and how much chlorine was necessary to form the product. In this case, the reaction is the reaction between sodium metal and chlorine gas to form sodium chloride. We first start by balancing the equation. We have to put a 2 in front of sodium because chlorine is a diatomic gas. So you're going to need 2 chlorines on the left, need to be balanced by 2 chlorines on the right. So we have to put a 2 in front of NaCl, which then necessitates putting a 2 in front of the sodium. Now that we have the balanced equation, these numbers, these coefficients, 2, 1, 2, represent the stoichiometry of the reaction. And they will allow us to go from moles of one substance to moles of another substance. We're starting off with grams of sodium chloride. And the grams of sodium chloride will be converted to moles of sodium chloride. We'll go through the stoichiometry to then find the grams of sodium and chlorine. So we began by taking the 82.59 grams of sodium chloride, dividing by the molar mass of sodium chloride, which is the sum of the molar masses of sodium and chlorine. Found out that we had 1.413 moles of sodium chloride. We then proceeded to find out the stoichiometry of the reaction, which was 2 to 2 between sodium and chlorine and sodium chloride. Notice I put sodium chloride on the bottom because I wanted to eliminate moles of sodium chloride. When I eliminate that, I get an answer in moles of sodium, and that is 1. Because it's 2 over 2, it's the same number. We get 1.413 moles of sodium. I then multiply the moles of sodium, and here, to get grams of sodium, I multiply by the molar mass of sodium to get the grams of sodium produced by the reaction. And then I restate the answer in the number of significant figures that I'm allowed. I'm only allowed 4 significant figures, so we generate 32.49 grams of sodium, according to our calculations. In the second half of the calculation, we're now going to determine from moles of sodium chloride how many moles of chlorine are necessary. So here the stoichiometry is 1 to 2. Again, we put 2 moles of sodium chloride in the denominator so that we can eliminate moles of sodium chloride to get an answer which is in moles of chlorine. We start off with the same number of moles that we obtained from this first calculation, divided by 2 to get 0.706 moles of chlorine. We then multiply by the molar mass of chlorine, multiply by 2, recalling that chlorine is a diatomic gas. And it gives us 50.101 grams of chlorine gas. We then report it to 2 decimal places, 4 significant figures. And then I made a last statement. This is typical of what you would put in an exam question. At the end of your problem, once you finished all your calculations, you would say, to make 82.59 grams of sodium chloride would require 50.10 grams of chlorine gas and 32.49 grams of sodium. The next problem approaches the same equation, but from a different angle. This time, they tell us you have 25.82 grams of sodium, and you want to know how many grams of chlorine are necessary to use up all of this reagent. So we begin by calculating how many moles of sodium are present, 1.123, so we're dividing by 22.98977, which is the molar mass of sodium. And from the moles of sodium, we multiply it through by the stoichiometry of the reaction. 2 moles of sodium require 1 mole of chlorine gas. So again, the moles of sodium appear on the bottom so that we can cancel them, and we'll have an answer that's in moles of chlorine. This number divided by 2 gives you this number. The answer is in moles of chlorine. Then to convert moles of chlorine into grams of chlorine, we multiply by the molar mass of chlorine gas, and we get the answer, 39.817 grams, which we then report to 4 significant figures. Notice how we round the 1/7 to 2, 39.82 grams of chlorine.
I want to show the